Hello and welcome to Math Lessons with Linda. Today's topic is logarithm properties and solving log equations using log properties. So let's get right into it. Our first problem is log base 6 of x minus 3 equals 2. Let's do a quick review of what all of these values mean in our problem. The 6 is the base. The x minus 3 is called the argument, and the 2 is the exponent. So when we're solving a question like this, some of you do like the loop property, which goes like this, and it's how you turn a log equation back into an exponential equation so you can solve it more easily. So if you're starting with 6, which is the base, and you loop around, the first thing you get to is the 2. That's your exponent, so it's 6 squared. Then equals is what you get to next, and then x minus 3. So this looks a little less intimidating now that it looks more just like a regular algebra equation. So I get 36 when I square equals x minus 3. And to solve, I'm just going to add 3 to both sides, and I'm going to get 39. And when I plug this back in, 39 minus 3 would be the same thing as 6 squared, which is 36, and I have that one correct. So that's a pretty straightforward one just to get you warmed up. We're going to do one that has a little bit more to it in our next problem, and it's going to use some more properties of logarithms. Log base 7 of x minus 2 plus log base 7 of x plus 3 is equal to log base 7 of 14. Now, when you have a log equation, it's really preferable when all of your bases are the same. It gives you more options of using some of these log properties. Another thing to remember that's very important as you get into more complicated equations is that these values that are called the arguments, when they have a variable in them and you solve your problem, you need to verify that when you plug in your solutions, you don't get a negative value for the argument, because the argument can never be a negative number. So let's keep that in mind as we go through. So on this problem, I have 2 separate log statements. They do have the same base, so I have options for using some of my log properties. One of those properties says that when you are adding together 2 logs and they have the same base, you can combine them into one log. So I would do log, I'd keep my base 7, but what I do with the arguments is I multiply them together. So this kind of shrinks my problem down a little bit, and it's going to make it a little bit simpler to have fewer terms. The other side, there's nothing for me to do right now. I'm just going to keep on with that. So now I need to FOIL this out, right? So I need to have log base 7, and I'm going to multiply this out, and I'm going to get an x squared plus x minus 6. That is after I combine all of my like terms. Now, another property of logs is that if I have 2 log statements, one on either side of my equation, if they are the same base, then I can drop the log statement and make the arguments equal to each other. And the reason I can do that is because I'm saying to my 7 raised to some power equals this, and 7 raised to some power also equals this. So these 2 values that are my arguments would have to be equal in order for this to be true. So I'm going to drop my log statements, and now I just have a quadratic to solve. So I'm going to subtract 14 from both sides. So I will have x squared plus x. Now I have minus 20 equals 0. And this becomes a factoring problem at this point. I'm going to get 2 different solutions. So let's factor this out. X times x, I think probably 5 and 4 multiplies to 20. I need a positive 1x. So the 5 has to be the positive and the 4 is the negative. Last step, solve for x. I get a -5 and a +4. So here are my two solutions. I want to make sure the one thing that I cautioned you about was having a negative argument. So if I plug in -5, let's go back to the top. If I plug in -5 here, I have -5 minus 2, and that is a -7. I cannot have a negative argument. I don't even need to check my other argument. I'm going to reject my answer where I got -5 for x. Okay, now my other one is 4. So let's see what happens when I do that. So up here, I'm going to have 4 minus 2, which is 2, works out fine. Over here, 4 plus 3, which is 7. So I'm good. And let's take a look and make sure that our answer actually checks out. Remember that we multiply our arguments together when we are adding. So 2 multiplied by 7 gives me 14, and that checks out with my answer on the other side of my equation. And so that is another example of how to work with logarithm equations using some of our properties.